fractions things, right? So don't worry about it, unless you want to.
I'm going to do it.
All right, do it.
Lights, camera, fractions.
I just have noticed lately it's been like more like lights, cam, fractions, right? Like it's been a little dull, and it sort of looks, it's sort of kind of whatever. I don't care. If you don't do it, it's fine. But all right, so I mentioned, I think in the last lecture or 2 lectures ago, I said there are 3 ways that we're going to learn to solve systems of equations. The first one was by graphing, right? The second one was by an algebraic method called substitution, which you guys all now know. And the third way is called elimination. It's the terminator method, right? You get rid of it, right? You eliminate it.
Can you please draw Terminator for us?
Okay, what?
Can you draw Terminator for us?
No, thank you. I'm not. It would be a stick figure, you know. So it
That's okay, that's
it wouldn't
okay.
be very impressive,
It's okay, Gary.
right?
Oh God. Can you draw Terminator?
That's Terminator, right?
Oh, Terminator over him.
It's going to give you nightmares for weeks.
Oh,
Right? Okay. All right. All right. So, if you look at that equation, or those 2 equations, and you said, cool, I know how to use systems, I know how to solve systems by substitution, bless you, by the way. It's sometimes dangerous to be at the front of the class, like near somebody, like, you know, they, you know, and like, oh.
Like hurt my throat
Okay?
so bad.
I'm sorry. All right. So if I use, so guys, listen to this. This is important. So Gavin, looking behind you, right? If I use substitution method, let's just see what it would be like, okay? And then we might have an understanding or an appreciation of the fact that there is another way to solve this, okay? So watch this. If I use substitution method, I'm just going to use the top one. 2x plus 3y is equal to 11, okay? So let's say I subtract 2x from both sides, right? Because I have to say y equals, right? All right, so I have 3y is equal to negative 2x plus 11, right? You with me? Okay, so now I'm going to divide by 3, right? Because it has to say y equals, not 3y. Divide by 3, divide by 3. So I get y is equal to negative 2/3 x plus 11/3. Awesome! Now all I have to do, this is your favorite part, is take something really simple like that and substitute it into the y here, right?
That's not simple.
Wouldn't that be fun and exciting and very easy?
No.
Oh my God, it would be a nightmare.
No, you can
Don't
do
you agree
3.
with
You
me?
can divide by 3. On all of them. See, because
No, because that's what y equals. I have to leave it there. So I've got to put that in there. That would be really hard. I mean, it's totally doable. You guys agree with me? But it's hard. And you would kill me if I gave you those problems, right? You would kill me, right? So I would never give those to you because I value my life, right? All right, so hopefully there's another way. There's so much noise.
that's the other.
Hopefully there's another way to do this that is way easier. So I'm going to erase my little circle around the y. Erase this. All right. Now, does anybody notice anything? If just look at those 2 equations, and just like sky's the limit. Can you imagine? Can you see any way? Remember, this is called the elimination method.
You would add them together. You would get rid of it.
Wait a minute, Harrison, what are you saying?
You could combine them because they're both have all electrons.
Oh my gosh. Look at this. We have our x's right above and below each other. We have our y's right above and below each other, and our numbers above and below each other, and our equal signs are in the same place, right? And if we did that, this is very interesting. I don't know. Maybe this is going to work. Let's just see. If we decided to add both of the equations together, let's see what happens. What is 2x minus 2x?
0x.
0x, meaning we eliminated it. We eliminated it.
Yeah.
Right? That's awesome. Okay, what do I have?
Not
I have
even x there anymore. No,
No.
not even an x.
now. What is 3y plus 5y?
Oh, it's 8y.
8y equals what's 11 plus 23?
What, you 23.
24. Right? Oh wait, what is, now I just divide by 8.
Yeah.
Divide by 8. Y is equal to 3. Oh my god, that was so easy.
Yeah. Oh my
Look
God.
at that.
Oh, true.
In literally 2 steps, we just found y. Versus substituting negative 3/2, or whatever it was, 2/3 x plus 11/3, right? Okay, Alec.
How do we get x?
Okay, so with x, to find x, you plug the y into either of the 2 original equations. So I'm going to just choose, the top one. So 2x plus 3y
Or 9.
equals 11. And so, guys, so y is 3, right? I'm going to replace this y with a 3. So I have 2x plus 3 times 3 is equal to 11. Right? You with me?
Yeah.
So I've got 2x plus 9 is equal to 11.
Subtract 9 and then
Subtract 9.
equals
2x is equal to 2. Divide by 2, x is equal to 1. Right? So we just figured out really, really easily what our answer was. Again, you could write your answer in a coordinate point too, 1, 3. Either one of those is a correct answer. Okay, either this or this are both correct answers. But look at that. By adding 2 equations together, you can solve them very easily, especially if they're both in the same format, ideally in standard form, right? Notice these are both in standard form. The x and y's are both on the left side of the equal sign, right? You make sure the x's are above each other, the y's are above each other, and the numbers are above each other. You draw your line, you add them, and then suddenly, in no time, you have simplified what could have been a really, really complicated problem. If we had used substitution, it would have been quite complicated to do. But so that's the beauty of having all these tools in your tool belt, right? I'm giving you all these tools to solve systems of equations. One is by graphing, right? What's the problem with graphing? It's a problem. What problem though? What's the problem with graphing? So, Alec. It's very hard to get it accurate.
It's hard
And it's easy to make mistakes with the graphing, right?
hard to know when they
Yeah, exactly where they meet. If they don't meet right on that grid corner line thing, oh my God, it's a nightmare, right? You can't do that. So then, first way is by graphing. The second way, the second tool I've given you is by substitution. And the third tool I've given you is by elimination, right? All of these are different ones that you can use. Now, most of the time, you're going to be using substitution and elimination. The graphing is not so, is kind of less useful in one way. But the thing about graphing, the reason why I teach it in the beginning is it helps you to understand what you're actually looking for, right? You're looking for that point where the 2 graphs, 2 lines intersect on the coordinate plane, right? But now that you understand that, it's okay to use these algebraic methods to actually get your answers, right? So sometimes systems of equations by substitution is by far the easiest way to do it. By far the easiest way. Sometimes systems of equations, solving them by elimination, by far the easiest way to do it, right? You see what I'm saying? So, to me, this is magical. I mean, like, who on earth would have thought to just add, besides Harrison? I mean, his brain, I don't know where it comes from, right? It's from planet Neptune. But, I mean, who else would have thought of just adding two equations together and suddenly it worked, right? I think that's magical, right? I think that's magical. So, isn't that cool? Isn't that cool? That was so easy to do.
I like this way better than
Right? Yeah, it's easy, it's pretty easy. But it's not always the easiest way. It's not always the easiest way. Sometimes the substitution is easier. But as long as you understand both, it's not a problem. You can always use this, right? You can always use this. The only thing is, think about it. What if I had two equations and they were not written both in standard form? They didn't have your x and your y on the left side equals a number, right? Then suddenly they're not lined up. So then you have to move your equation around, right? Wouldn't it be easier sometimes to just substitute that thing in for the y? You know what I'm saying? So I mean, it sort of depends on how the information or the problem has been given to you, right? Make sense? All right, so that's the first one. Let's try another one and see if we can make sense of this. Okay, let's see, let me find one. Okay, let's try this one. So we've got 4x, this is number 2. So 4x minus 3y equals 5. Minus 3y equals 5. And we have negative 2x plus 3y equals negative 7, plus 3y equals negative 7, and then okay. Okay. All right. So here we go. Now, I would not want to do this by substitution again, would you?
No.
It would be a nightmare. It would be an absolute nightmare. So I'm going to do it with elimination. I'm going to take our friend Harrison's idea, and I'm going to just add them together. And in the process, what gets eliminated this time?
Harrison does.
Everything gets eliminated. No, not everything.
3y.
Right, 3y gets eliminated. These get eliminated. So I have 4x's minus 2x's. So I have 2x. Those, I don't have to write plus 0 because plus 0 is nothing, right? So 2x equals 5 minus 7, negative 2. So I'm going to divide by 2, x is equal to negative 1. That is so simple.
Oh yeah.
Right? That is so simple. That is awesome. So now what I'm going to do, what do I do with that now?
Then you plug that in.
I got to plug it in. So I'm going to just use, and you can use either equation. I just always choose the one that looks easiest to me, right? You might like the negatives, and so you might choose this one. But I kind of steer away from the ones with tons of negatives, because negatives are where people tend to make mistakes, including me. Right? So I see, did I write that right? Yes. X is equal to negative 1. It's exactly, so this x is going to have to be negative 1. 4 times negative 1 minus 3y equals 5. So negative 4 minus 3y is equal to 5. Are you guys writing? Gavin, you writing this down?
Yeah.
Are you sure? You guys really writing this down?
I'm writing it down.
It's important. All right. So now I'm going to add 4. Add 4. I've got negative 3y is equal to 9. And I'm going to divide by negative 3. Divide by negative 3. Y is equal to negative 3. Great. So I've got y equals negative 3.
Y equals 2,000 actually here.
Right? So the negative divided by negative becomes a positive. Right? Positive divided by negative becomes a negative. Right? So negative 3. Does it make sense? All right. So that's how it works. Fist of 5 on elimination. Awesome. So I'm going to give you the homework. I'm going to stop this thing.
You're going to make a meme of Caleb. Why he